Okay, hello, precious one. I welcome you once again into Kenya Mathematics Classroom. On this particular episode, we are still looking at continuation of polynomial functions, and today we are going to look at what we call the remainder theorem. We have what we call the factor theorem, and we'll be looking at what we call the zeros of a polynomial function. So we are going to start with the remainder theorem. What we call the remainder theorem. Remainder theorem. Now, what is happening is if the polynomial f of x is divided by x minus a, then the remainder is given by f of a. Similarly, if the polynomial f of x is divided by x plus a, then the remainder is also given by f of minus a. Okay, so now this is what the theorem is saying, that if you have, when the polynomial f of x is divided by x minus a, that means that the polynomial is the dividend and x minus a is the divisor, then the remainder is given by f of a. Now I'll explain why we have f of a. Then similarly, if f of x is divided by x plus a, then the remainder is given by f of a. Now what is happening is, we are saying that if f of x, that's the polynomial function, is divided by x minus a, then the remainder will be equal to f of a. Then if the polynomial function is divided by x plus a, then the remainder will be equal to f of minus a. What is really happening is, when you divide a polynomial function by this is the dividend, we have the divisor. What is happening is, when we equate the divisor to 0, x minus a equals 0, and we make x the subject, x equals a. So f of a means that when we substitute a, wherever we see x in the polynomial function, whatever we are getting is the remainder. I will explain with an example so you understand it better. But when we have f of x divided by x plus a, then the remainder will be f of minus a. That means that when you also equate the x plus a to 0 and you make x the subject, you are getting minus a. Then when you take minus a, wherever you see x in the polynomial function, whatever you are also getting is what you call the remainder. That is what is really happening here, and I'm going to explain. So if the polynomial function is divided by x minus a, then the remainder is given by f of a. And similarly, if the f of x, the polynomial function, is divided by x plus a, then the remainder is given by f of minus a. Now, I'm going to give you a question based on this so that we will see what we are talking about here. I'm going to make it very simple for you to understand what we mean by the remainder theorem. Now, let's take a question, and let's assume that we have to find the remainder. We have to find the remainder when the polynomial f of x equals x squared minus 5x plus 6 is divided by x minus 1. Okay, so this is the question that we are given. We have to find the remainder when the polynomial x squared minus 5x plus 6 is divided by x minus 1. Is divided by x minus 1. Now, the polynomial is x squared minus 5x plus 6 divided by x minus 1. So x squared minus 5x plus 6 is our dividend, then x minus 1 is our divisor. And I guess by now you understand that based on what you did in the division of polynomials. Now, if you want to use the division of polynomial approach, the x minus 1 is the divisor outside. So that will be outside. You have x minus 1 Then the dividend is x squared minus 5x plus 6. So if you remember, with the division of polynomials, we said that you now divide x squared by x, and that will give you x. Then you multiply x by the divisor. So x by x will give you x squared. Then x times minus 1 will give you minus x. Then you underline, so you know where your minus and the bracket is. So x squared minus x squared minus x squared is 0. Then minus 5x minus x will be minus 5x plus x. And that will give us minus 4x. Then the only term we have up there is plus 6. So we bring it down. Then we start the division again. Minus 4x divided by x will give us minus 4. So we are going to have minus 4. Then minus 4 times x will give us minus 4x. The minus 4 times minus 1 will give us plus 4. So we underlined. Then our bracket here and our minus here. So we have minus 4x minus 4x will be minus 4x plus 4x. And the x term is gone. So we have 0. Then we are going to have 6 minus 4. And the result is 2. So you see that when we divide this by, that is x squared minus 5x plus 6 by x minus 1, the remainder is giving us 2. The remainder is giving us 2. If you remember, so we said that when we divide this by this, now the answer, what we had, the quotient is x minus 4. The remainder is now giving us 2. We divide this by the x minus 1. That is the expression. Now, situation where your remainder is giving you 0, this expression will be off. And I guess you understand that. When you refer to my presentation on division of polynomials, you understand what I'm talking about here. So, when we divide x squared minus 5x plus 6 by x minus 1, we are getting x minus 4 as the quotient plus the remainder over x minus 1. But we are interested in the remainder. And so the remainder is 2. So when you divide this by this, you have to find the remainder. The remainder is 2. But by the fact that the remainder theorem, from the remainder theorem, we said that, if you remember, that we have the polynomial function, this x squared minus 5x plus 6. And our divisor is x minus 1. We said that now, when we equate this x minus 1 to 0 and you try to make x the subject, you now add 1 to both sides. So we have x minus 1 plus 1. Whatever you do to the left hand side, you do the same to the right hand side. So minus 1 plus 1 is gone. So we are left with x equals 0 plus 1 is 1. Now we are saying that if you want to find your remainder will now be, f of 1. That is whatever you get after equating it to 0. Whatever you get, you now take it back. So f of 1. Now, when we say f of 1 is the same as, it's a function notation. That means wherever you see x in the polynomial function, you substitute that by 1. So f of 1 will be equal to, instead of x squared, it will now be 1 squared minus 5 times x is 1 and plus 6. 1 squared is 1 minus 5 plus 6. 1 minus 5 is 4. 1 minus 5 is minus 4. So plus 6 will give us 2. So do you see that we are also getting the same 2 we had here? That's what I'm talking about. So when you are given the question, you can use the remainder theorem approach to solve the remainder without the division of polynomials. So in general, that's what is happening. So when you are given a polynomial function and you are told that when you divide that polynomial function by a divisor, you are asked to find if you are asked to find the remainder when a polynomial function is divided by an expression, then what you have to do is equate the divisor to 0 as we did here and make x the subject. Whatever you get for x, you take it back into the function. The answer will be your remainder. So when we talk about remainder theorem, that is what we are actually talking about. That's what we are actually talking about. Now, let's take a look at another question and see how best. Let's assume that we were given the same f of x to be x squared minus 5x plus 6. And we have to find the remainder. That remainder is question mark. If the divisor is x minus 2. Okay. So here we have to find the remainder when the polynomial is divided by x minus 2. So if it's divided by x minus 2, then it means that your divisor is x minus 2. So what you do is you equate the x minus 2 to 0. then you try to make x the subject. X will be equal to 2 here. So the remainder will be equal to f of that 2. That's what we are talking about. That is all. F of that 2. So remainder will be equal to f of 2. F of 2 means that wherever you see x in the expression, you now substitute that by 2. So instead of 2 square, you are going to, instead of x square, you are going to have 2 square minus 5 times 2 plus 6. The remainder will be f of 2, and that is 2 square is 4 minus 5 times 2 will be 10. Then you have plus 6. 4 minus 10 is minus 6, and minus 6 plus 6 will be equal to 0. That means that when you divide the polynomial by this, the remainder will give you 0. That's the meaning. Now, you can try that with the division of polynomial approach. Try to divide this expression by the divisor x minus 2, and you see that the remainder will give you 0. So that's what you are talking about. If it's an objective question, you don't have to go through the division of polynomial approach. You rather equate your divisor to 0. Make x the subject. Whatever you are getting for x, take it back into the expression. What you get is your remainder. And that is what we are talking about. That is what the remainder theorem is all about. That is what the remainder theorem is all about. So if you are asked to find the remainder when a polynomial is divided by an expression, just equate that expression to 0. Make x the subject. Whatever you are getting for x, take it back into the original question and try to find the value. Whatever you get is what we call the remainder, is the remainder. Now we are going to look at what we call the factor theorem. What we call the factor theorem. Factor theorem. Now, what the factor theorem is always saying is this: if the polynomial f of x is divided by x minus a, and f of a equals 0, then x minus a is a factor. Is a factor of the polynomial f of x. Then similarly, if f of x is divided by x plus a, and f of minus a is equal to 0, then it means that x plus a is also a factor. Is also a factor. You see, what we are talking about here is very simple. What we are saying is this. I'm going to explain this with a simple expression for you to understand what we are saying. Now, when we divide 12 by 4, the result is 3. The remainder is 0. Because we are getting remainder 0, that means that the 4 is a factor of 12. Now, when we divide 12 by 3, the answer is 4. Remainder 0. Because the remainder is 0, it means 3 is a factor of 12. But when we divide 12 by 5, this 5 goes in here 2 times, plus the remainder is 2 over the divisor again. When you simplify the right hand side, you will still get this. Now, because there is a remainder, it means that 5 is not a factor of 12. That's what we are talking about here. So that's the factor theorem. But now we are going to solve some questions so that you understand what we mean by a factor theorem in general. So if the polynomial f of x is divided by x minus a, and f of a equals 0, take note, when it's divided by x minus a, f of a equals 0. This f of a is the remainder. If you remember, we said that when you equate the divisor to 0, you make x the subject. Whatever you get, when you take it back into the function, is your remainder. So if your remainder is 0, then it means that that divisor is a factor. That's what we are talking about. So if 12 divided by 4 is giving us 3, and the remainder is 0, then it means that the 4 is a factor. If 12 divided by 3 is giving us 4, and the remainder is 0, that means 3 is a factor. But 12 divided by 5 here equals 2, plus there is a remainder of 2 divided by the divisor. Because there is a remainder, it means that 5 is not a factor of 12. That is what you are talking about. So when you are given a question, you can be given a question and you'll be asked to determine whether the given divisor is a factor or not. Now let's assume we are asked to determine whether x minus 2 and x minus 1 are factors of f of x equals x squared minus 5x plus 6. We are asked to determine whether x minus 2 and x minus 1 are factors of this. So now we are given the polynomial. The polynomial is f of x equals x squared minus 5x plus 6. And we are given x minus 2 and x minus 1 to determine whether they are factors of this polynomial. Now, to determine, what we do is, the first one we are given is x minus 2. So we equate it to 0. We make x the subject, and the answer is 2. Then we take 2 back wherever we see x. So we say f of 2. Now, wherever we see x, we substitute that by 2. So we have 2 squared minus 5 times 2 plus 6. And 2 squared is 4. We have minus 5 times 2 is 10 plus 6. And 4 minus 10 is minus 6 plus 6. And in all, this is giving us 0. That means that f of 2 is giving us 0. So do you see that this is how we find the remainder? So because the remainder is giving us 0, it means that x minus 2 is a factor. It means that x minus 2 is a factor. Now, let's try to solve the other one. We were given x minus 1. So we also equate to 0. Make x the subject, you will get 1. Then f of 1 will now be, the expression is x squared minus 5x plus 6. So we are going to have 1 squared minus 5 times 1 plus 6. Then f of 1 here will be 1 squared is 1. 5 times 1 is 5 plus 6. And then 1 minus 5 is minus 4 plus 6. So f of 1 is giving us 2. So do you see that now this one has a remainder? This one give us a remainder of 0, so no remainder. So because the x minus 2 gave us a remainder of 0, it means that x minus 2 is a factor of this polynomial. But because x minus 1 did not give us a remainder of 0, but rather give us a remainder, that is 2. That means that x minus 1 is not a factor. That's what we are talking about. That is everything we have here. That is the explanation. So if you want to determine whether an expression or a function is a factor of a polynomial, you only equate that to 0. When you equate the expression to 0, make x the subject. Then take it back into the expression. If you are getting a remainder of 0, then that expression is a factor of the polynomial. But if you are getting a value other than 0, if you are getting a remainder, then it means that that particular expression is not a factor. So in this case, when you compare the two, you realize that because this one gave us 0, then it means that the x minus 2 is rather the factor of this, but this is not a factor. So that is what we are talking about. So that is what we are talking about. This is the factor theorem. When we say factor theorem, that's what we are talking about. So when you are given a polynomial, and you are given divisors, and you are asked to determine whether they are factors, you just try to find the remainders. How we find the remainder? From the remainder theorem. If you are getting 0, then that divisor is a factor. But if you are not getting 0, then it is not a factor. That is what the factor theorem is talking about. Now there is something I want us to look at, and we call it the zeros of a polynomial function. The zeros of a polynomial function. The zeros of a polynomial function. Now, the zeros of a polynomial functions are the values of x for which that polynomial function is equal to 0. That is all. So, if the polynomial function is equal to f of x, then the zeros, if you want to find the zeros are the values of x for which that polynomial function is equal to 0. That is all. For which that polynomial function is equal to 0. Now, what are you talking about here? Now, assuming we are asked to find the zeros of the function, f of x equals x squared minus 5x plus 6. Now, if you have to find the zeros of this function, what you are saying is the zeros of a polynomial function is when the polynomial function is equal to 0. So, if the polynomial function you are given is x squared minus 5x plus 6, then for the zeros of that function, we have to equate the function to 0. That is all. And the function given in the question is x squared minus 5x plus 6. So when you equate this to 0, then this one becomes a quadratic equation. That means solve it. That's all. So if you want to find the zeros of a polynomial function, that means equate the polynomial function to 0 and solve for x. Whatever you are getting are the zeros of that polynomial function. So I guess you understand that. So now this is now a quadratic equation, and if you don't know how to solve a quadratic equation, you can refer to my presentation of quadratic equations and you understand it. Now, you see that the coefficient of the square term here is 1. When you multiply 1 by the constant, you are getting 6. So you are going to find factors of 6 in such a way that when you multiply, you get 6, but when you add, you get the coefficient of the x. That's all. And the numbers are 2 and 3. The numbers are 2 and 3. The numbers are 2 and 3. So you simplify. Now, it's x squared, then you have minus 2x minus 3x plus 6 equals to 0. You see that minus 2 times minus 3 will give us plus 6. But minus 2 minus 3 give us minus 5. That's what we are saying. So you multiply the coefficient of the square term by the constant. Then you search for factors of that result. So 1 by 6, 1 times 6 is 6. Then 2 factors. When you multiply, you get positive 6. When you add, you get coefficient of the x term. And the numbers are minus 2 minus 3. Because when you multiply minus 2 by minus 3, you are getting plus 6. And when you add these two terms, you are getting minus 5. So you simplify. You factor x out, you have x minus 2 in here. You factor minus 3 out, you have x minus 2 in here. Our advice is if you don't understand how quadratic equation is solved, you refer to my presentation on the same platform, Kenya Mathematics Classroom. You watch my presentation on quadratic equation, how to solve it, you understand it better. Now, we group what we have outside. We have x here, then we have minus 3 here. We keep it in one bracket. Then these and these are the same, so we also maintain one of them, and we equate this to 0. So now x minus 3 is equal to 0. When you solve for x, you get 3. Then x minus 2 equals 0. When you solve for x, you get 2. If you have any question, you can send your question in the comment section. I will solve it for you. I will explain it for you on this same platform, Kenya Mathematics Classroom. So if you have not subscribed to the channel, I will advise that you subscribe to the channel, you share the video, share the presentation, let somebody know about the page, let somebody know about the platform, so that whatever you are doing can also benefit others. So in all, that's what we call the zeros of a polynomial function. So for the zeros of a polynomial function, you just equate the function to 0 and solve for x. That is all. So in general, that is what we call the remainder theorem. In general, that's what we know. That's what we have about the factor theorem. And these are the zeros of a polynomial function. These are the zeros. How to find the zeros of a polynomial function. So we are going to solve 1 or 2 questions, and that will be all on this particular episode. Okay, so assuming that we are given, let's see how best we can solve this problem. Assuming that we are given, let's use the same quadratic expression, x squared minus 5x plus 6. And you have to find the remainders when f of x is divided by I. We have x plus 2 I. Then we have x plus 3 I, we have x minus 2, then we have IV, we have x minus 4. Now, this is a polynomial function x squared minus 5x plus 6, and we have to find the remainder when the polynomial is divided by, and these are the divisors. So if you want to find the remainder, you know that from the remainder theorem, if you want to find the remainder, you only equate the divisor to 0 and solve for x. This will give minus 2. Then you now find f of minus 2. That means wherever you see x in the expression, you substitute that by minus 2. So you have minus 2 squared minus 5 times minus 2 plus 6. And this is minus 2 squared will give us 4. Minus 5 times minus 2 will give us plus 10. Then we have plus 6. And 4 plus 10 will give us 14. And 14 plus 6 will give us 20. So when we divide f of x by x plus 2, the remainder will give us 20. And our advice that you use the division of polynomial, divide this by this according to the division of polynomials, and see your remainder whether it is equal to 20. That is how we learn. So get your book, your pen, your calculator, then you sit down and try to divide this polynomial by this expression to see whether you are also going to get the remainder of 20. So in general, that is how we solve for that. Now, the divisor is x plus 3. So x plus 3, you have to equate that to 0. You solve for x and you are getting minus 3. If you want to find the remainder, it's f of minus 3. That means wherever you see x, you substitute that by minus 3. So we have minus 3 square. We have minus 3 square over there. Minus 5 times minus 3. Then we have plus 6. And minus 3 square is 9. Minus 5 times minus 3 will give us plus 15. Then we have plus 6. Okay, so 9 plus 15 will give us 24. And 24 plus 6 will give us 13. 24 plus 6 will give us 30. That means that when you divide the polynomial by x plus 3, the remainder will give you 30. So take note that when we divide f of x by x plus 3, when we divide this by this, the remainder gave us 20. That means that x minus x plus 2 is not a factor. I guess by now you understand the difference between the remainder theorem and the factor theorem. So now if you have x plus 2 and you want to find the remainder, you only equate the x plus 2 to 0, make x the subject and take it back into the equation. If you are getting 0, then it means that that divisor is a factor of the polynomial. But if you are not getting 0, then it means that it is not a factor. Now, when we divided it by x plus 3, we equated to 0, x plus 3 to 0. We made x the subject, we have minus 3, and we did the substitution, and we are getting 30. Because the remainder is not giving us 0, but rather 30, a number, that means that x plus 3 is also not a factor of the polynomial. So, I advise that you try this, equate this to 0, make x the subject, take it back and see what you are getting. Equate this to 0, make x the subject, take it back into the equation, see what you are getting. If you are getting a remainder of 0, that means that particular divisor is a factor. But if you are not getting a remainder of 0, then it means that it's not a factor. So that is about the factor theorem and the remainder theorem. That is all. So that is what we know about what we have about the remainder theorem, the factor theorem, and what you call the zeros of a polynomial function. So that will be all for now on this particular episode. Until I come your way again, it's a bye-bye for now.